Morning. I'm V.Srinivasa, Reddy, Associate Professor of Mathematics, Government Degree College, Ramannapet. This is my sixth video lesson on differential equation. So today I will talk on total differential equation. When you say total differential equation is a integrable, what is the condition for total differential equation? How to solve the total differential equations? And we see some problems on total differential equation. See, first we see definition of a total differential equation. So any ordinary differential equation, any differential equation of the first order and first degree, which involves three variables, is of the form p plus q dv by dx plus r dz by dx is equal to 0, or p dx plus q dy plus r dz. This can be written as p dx plus q dy called r plus r dz, where p, q are functions in x and x is an independent variable, is called total differential equation. So an equation of the form p plus q dv by dx plus r dy by dx, this can be written as p dx plus q dy plus r dz, is called a total differential equation, where p, q are functions in x and x is independent variable. So the total differential equation p dx plus q dy plus r dz is integrable if p into dou q by dou z minus dou r by dou y plus q into dou r by dou z minus dou p by dou x, dou p by dou z, plus q into dou r by dou x minus dou p by dou z, and plus r into dou p by dou y minus dou q by dou x equal to 0. So how to solve the total differential equation? So when how to solve the total differential equation p dx plus q dy plus r dz equals 0. First, we verify the condition of integrability, whether it is integrable or not. For find p into dou q by dou z minus dou r by dou y, and plus q into dou r by dou x minus dou p by dou z, or plus r into dou p by dou y minus dou q by dou x. If it is 0, then the given total differential equation is integrable. Or this simply we can write simply determinant of PQR and dou by dou x, dou by dou y, dou by dou z, PQR. So find simply find the determinant PQR, dou by dou x, dou by dou y, dou by dou z, PQR. If it is 0, then the given total differential equation is integrable. Simple. Can find determinant of P, Q, R, dou by dou x, dou by dou y, dou by dou z, P, Q. If it is 0, then the given total differential equation is integrable. So how to solve this when it is integrable? How to solve this total differential equation? Take one of the variables, say z, as constant, or you may take any. Here three variables are there: x, y, z. You may take anything, either x or y or z can be taken as constant. For example, if I take one of the variables, say I will have taken here z as constant, dz equals 0. This can be solved also by taking x is constant or y is constant. So z as constant, then dz equals 0. So automatically here p dx plus q dy plus r dz equals 0. Dz equals 0. That means we'll get p dx plus q dy equals 0. Now integrate. So when integrating, we'll get some integrate with respect to x, and we're taking y, z, we're taking z as constant. Take z as constant. So integrate this equation. When integrating z, z be taken as constant. So, and then we are integrating, we get some constant. That constant will be taken as phi z, because here we treat z as constant, then we get psi of x y z equal to phi z. So when our total differential equation is integrable, take one variable, say z is constant, then dz equals 0 and p dx plus q dy equals 0. So and integrate. When we are integrating, we need a constant. We take arbitrary constant as phi z. Okay. This can be solved. We can take x is also constant or y is also constant. Another method. After that, integrate in step 2. Integrate the we get the solution or the integral in the step 1. Obtain. Let now differentiate the integral obtained in step 1. In step 2. Step 2, the solution or the integral in uh, integral in step 2 in differentiate with respect to xyz and compare the given differential equation to find and compare this equation with the given differential equation to find f set. Now we get the solution psi of xyz equal to 5. So in step 3, now differentiate the integral in step 2. What we obtain, what we get in step 2, just differentiate with respect to x, y, and z, and compare the given differential equation to find phi z. So finally get the solution psi of x, y, z equal to phi z. So in this 3 steps are there, just simple. One, first verify the condition of the integrability. That is the determinant of PQR, dou by dou x, dou by dou y, dou by dou z, PQR equals 0. Once it is 0, then it is integrable. And in the step 2, take one of the variable. You may take either x or y or z. I will take here z as constant, say z, dz equals 0. Q dx plus q dy equals 0. Now integrate, taking z as constant. We get some psi of x by z. Here in place of c, I am taking phi z. So in step 2, just z as constant, dz equals 0, we get the solution. To find phi z, differentiate what we get in the step 2. Differentiate with respect to x, y, z, and compare the given differential equation. And from these two, we get phi z. Finally, solution is psi of x, y, z equal to phi z. And also, sometimes you get the solution by regrouping the terms in the given equation or integrating directly sometimes. So, or sometimes easily we can get the solution by regrouping the terms in the given equation and integrating, we get the solution. This is a we can observe by directly. Example, problem 1. See, solve y plus z dx plus z plus x dy, x plus y dz equals 0. So comparing with p dx plus q dy plus r dz equals 0. Here, p is equal to y plus z, q is equal to z plus x, r is equal to x plus y. So comparing with the p dx plus q dy plus r dz equals 0. Here, p is equal to y plus z, q is equal to z plus x, r is equal to x plus y. So now, first verify the condition of integrability. So we have to find determine PQR, dou by dou x, dou by dou y, dou by dou z, PQ. Here P is y plus z, Q is z plus x, and x plus y, R, dou by dou x, dou by dou y, dou by dou z. Here P is y plus z, Q is z plus x, r is x plus y. So here y plus z into dou by dou y of x plus y is 1 because of for x 0 or for y 1 minus dou by dou z of z plus x for z 1 for x 0 because we are doing partial derivative with respect to z, x we take as constant. That's why we'll get z plus x 1 minus 1. And then x plus y into so dou by dou x of z, z is 0 for x1. Similarly, dou by dou y of y plus z is 1. So finally, we are getting 0, 1 minus 1, 0, 1 minus 1, 0, 1 minus. Finally, we are getting determinant of PQR, dou by dou x, dou by dou y, dou by dou z, PQR is equal to 0. Therefore, given integral is integral. Therefore, given integral is integral. So now, how to solve? Once it is integral, we have to solve this equation. But here, it can be solved easily by regrouping. Here, the equation is y plus z dx plus z plus x dy plus x plus y dz, express the y dz equals 0. So you can solve easily by regrouping. Here we are getting y dx1, z dx, z dy plus x dy, x dz plus y dz. So we take one group as y dx, x dy. Another one is z dx plus x dz, and another one is z dy plus y dz. Finally, here we get 6 terms and regroup two terms. Y dx plus x dy one group, z dx plus x dz one another group, and another group is y dy plus z dy plus y dz. We know that y dx plus x dy is derivative of xy, derivative of xy or derivative of yx. So in order to derivative of u derivative of u into v plus v into derivative of u. So we can write this derivative of xy means x dy plus y dx. Similarly, we can second z dx z dz can be derivative of z, and third one we can write derivative of yz. So integrating will get xy plus zx plus yz equals c. You can integrating derivative and integration is cancelled. We'll get the directly xy plus zx plus yz equals c. So in this example, we can get directly the answer. So just regrouping y dx plus x dy one group, z dx plus x dz another group, and z dy plus y dz equals 0. So we can write the derivative of xy plus derivative of xz plus derivative of yz equals 0. So integrating, we get a solution xy plus zx plus yz equal to c. So this can be getting here in this problem, we're getting that. Second one, solve x plus z whole square, x plus z whole square dy plus y square dx plus dz, y square plus y square into dx plus dz. So here write in the form of p dx plus q dy plus r dz equal. So y square dx here plus y square dz plus y square dx plus y square dz and x plus z whole square d, x plus z whole square d. So comparing with p dx plus q dy plus r dz equal to, comparing with p dx plus q dy plus r dz equal to 0. So we'll get p is a y square, q is a x plus z whole square, r is y square. So now first we verify the condition of the integral, whether it is integrable or not. First we have to verify. So to verify this condition, just determine p, q, r, dou by dou x, dou by dou y, dou by dou z, p, q, r. So if this determinant is 0, then the given equation is integrable. Just we say p is y square, q is x plus z whole square, r is equal to y square. So, and again here p is equal to y square, q is the y x plus z whole square, y square. So first we have to verify the condition of the integral. So here y square into, so dou by dou y of y square. We know that the dou partial derivative of y with respect to y square, partial derivative of y square with respect to y is 2. And the dou by dou z of x plus z whole square. This is like x square, like z square, 2 into x plus z. And the derivative and the partial derivative of x plus z is 0 plus 1, 1. You get 2 into x plus z minus x plus z whole square into dou by dou x of y square. Dou by dou x of y square is a 0, and dou by dou z of y square 0. We'll get 0 minus 0, and plus y square into dou by dou x of x plus z whole square, 2 into x plus z minus dou by dou y of y square minus 2y. So we verify here we are getting 2y square here minus 2y into y square 2y cube. Here 2y into y square minus 2y cube. Finally we are getting these two are cancelled. 2y cube cancelled. And here we are getting 2y square x plus z minus 2y square x plus z. This is plus 2y square x plus z. Finally all these are cancelled. We get the answer 0. So finally we get It is 0, determinant is 0. That's why given equation is integral. Given equation is integral. So now we have to, when it is integrable, we have to find the solution of the given equation. But this equation you can find directly. So we can find the solution directly. This here given equation is x plus z whole square divide plus y square into dx plus y square into dx plus dz. Just dividing by y square x plus z whole square, you get dividing by y square into x plus z whole square, you get dy by y square, right? This side y square here and x plus z whole square here. So you get dy by y square plus dx plus dz by x plus z whole square. So we can solve this easily directly, integrating integral of dy by y square plus integral of dx by dz x plus z whole square. Here whole square is missing. Here x plus z whole square is missing. So x plus z whole square here. So we know that integral of 1 by y square. We know that integral of 1 by y square is minus 1 by y, because we know that derivative of 1 by y is a minus 1 by y square. That's why integral of, we know that integral of 1 by y square is minus 1 by y. So let t is equal to x plus z. Let t is equal to x plus z. So dt is equal to, we'll get dt is equal to dx plus dz. So taking t is equal to x plus z, dt equal to x plus z. So minus 1 by y plus dt integral dt by t square. Here missed, here x in place of x plus z also, just only x plus z is there. So get here dt by t square. Finally we get what is the integral of 1 by t square? We know that minus 1 by t. Here like 1 by y square is minus 1 by y. Here integral of 1 by t square with respect to t is minus 1. Finally we are getting minus 1 by y minus 1 by minus 1 by y minus 1 by t is equal to c. So here t is equal to, here t is equal to x plus z. So minus 1 by x plus z. So taking common minus 1. Here LCM is y into x plus z. LCM is y into x plus z. X plus z plus y by y into x plus z is equal to c. So finally we're getting x plus y plus z equal to, taking minus this side, minus c into y x plus z is equal to. Finally, we're getting, taking minus this side, x plus y plus z plus cy into x plus z equals to. So finally, to solve the equation p dx plus q dy plus u or dz, find determine, verify the if it is 0, given the equation is integrable. So here this equation is directly integrable. Just this is minus 1 by y. Here they're taking this is t, we get dt by t square. We get directly here minus 1 by y minus 1 by t plus minus 1 by y minus 1 by x plus z equals. So finally we are getting x plus y plus z equals minus cy into x plus. See third problem. Solve x dx plus z dy y plus 2z dz equal to y plus 2z dz equal to 0. Y plus 2z dz equal to 0. So here p is equal to x, comparing with the p dx plus q dy plus r dz equal to 0. Comparing with the p dx plus r dy plus p dx plus q dy plus r dz equal to 0. Here p is equal to x, q is equal to z, r is equal to y plus 2z. R is equal to y plus 2z. So first to find the condition of the integrability. So find that, to see that, to check that condition, and determine EQR dou by dou x dou by dou y dou by dou z PQR dou by dou x dou by dou y dou by dou z PQR. So here P is Q, X, Q is Z, R is Y plus Z. So dou by dou X, dou by dou Y, dou by dou Z, X, P is X, Q is Z, R is Y plus 2Z. So here X into dou by dou Y of Y plus 2Z, dou by dou Y of Y plus 2Z is dou by dou Y of Y plus 2Z is 1 because of for 2Z 0 and dou by dou Z of Z is 1. So X into 1 minus 1 and minus Z into dou by dou X of Y plus 2Z is 0. So minus dou by dou Z of X is 0 and plus Y plus 2Z into dou by dou X of Z is 0 minus dou by dou Y of X is 0. So finally we are getting PQR dou by dou X dou by dou Y PQR is equal to 0. So therefore determinant is 0. Therefore given equation is integrable. Once it is integrable, we have to find this solution. But this equation also can be found directly. So by regrouping, simply we see here x dx plus the z dy and it is a y dz plus 2z dz. So we can x dx can be directly integrable. So z dy plus y dz, this can be written as z dy plus y dz, this can be written as derivative of yz, derivative of yz. So plus 2z dz plus 2z dz. So integrating, we get integral x dx x square by 2. So derivative of yz is integrating derivative of integral of x dx equal to x square by 2. Derivative of yz is integration derivative cancel, we get yz, and the integral of 2z is z square by 2, integral of z is z square by 2, 2 will be cancelled by z square. Finally, we'll get x square by 2 plus yz plus z square equal to plus c, plus z square equal to c. So finally, we get the solution x square by 2 plus yz plus z square equal to c, plus z square equal to c. Just verify the condition PQR dou by dou x, dou by dou y, dou by dou z, PQR. So you get 0. So that means whenever it is determined is 0, then given equation is integral. So here this in this problem, you can get directly solution because by regrouping x dx, z dy plus y dz plus 2z dz equal to 0. This can be written as derivative of yz. This is a plus 2z dz. So integrating, you get x square by 2 plus yz, integral 2z is plus z square is equal to, and you get the solution. See another problem. Is solve y square plus yz dx plus z square plus zx dy plus y square minus xy dz equal to 0. Y square minus xy equal to 0. So comparing with the p dx plus q dy plus r dz equal to 0. Here p is equal to y square plus yz and q is equal to z square plus zx, r is equal to y square minus x. So first we check the whether it is integrable or not. To check whether it is integrable or not, find determine p q r dou by dou x, dou by dou y, dou by dou z, p q r. So here p is y square plus yz, q is z square plus zx, r is the y square minus x. So similarly, y square plus yz, z square plus zx, y square minus x. So first find the derivative. First find the determinant y square plus yz. Dou by dou y of y square minus xy. Dou by dou y of y square minus xy. For y square, dou by dou y of y square is 2y. For minus xy, here with respect to x, y is partial derivative. X is constant for y1. So we'll get 2y minus x. So for dou by dou y of y square minus xy, we'll get 2y minus x minus double dou z of z square plus zx is here we get minus 2z minus 6. So that's why I written minus 2z minus 6. Okay, once again we see y square plus yz dou y of y square minus xy equal to this is a 2y minus x and dou x of z square plus the zx equal to this is a minus 2z minus x and the minus z square plus zx minus z square plus zx into dou x of y square minus xy is dou x of y square is 0 and for minus xy minus 1 and dou z of y square plus yz for y square 0 for yz y we get minus 1 minus. So actually this is z square plus zx into dou x of y square minus xy minus dou z of y square plus yz. So finally we are getting dou x means here minus 1 minus dou z of y square plus yz means minus 1. So finally we are getting minus 1 minus 1, this is minus 2 and plus y square minus xy into plus y square minus xy into this is a dou x of z square plus zx. Dou x of z square plus zx for z square is 0 for z square z square is 0 for zx z and dou y of y square is a minus 2y minus dou y of y square plus yz is minus 2y minus z. For yz dou y of yz is z into 1, so minus z minus 2. So last term plus y square minus xy into dou x of z square plus zx is a z and dou y of y square plus yz is minus dou y of y square plus yz minus z minus 2. So to simplify, we'll get 0. You observe here y square into 2y cube. Here we are getting minus 2y into y square minus 2 will be cancelled. And then here minus 2z y square. Here we get plus 2z y square. It will be cancelled. And then minus xy square. Minus xy square. Here we'll get minus xy square is also cancelled. And then so minus 2y minus 2y z square minus 2y z square. Here we'll get 2y minus 2y minus 2y z square. So similarly, so minus 2xy y square will be cancelled, minus 2z y square will be cancelled, and then yz minus will get minus 2x xx 2x minus 2xyz. Here we'll get minus 2xyz plus 2xyz. It will be cancelled. So by simplifying, we'll get the 0. So finally here we are getting y square plus yz 2y minus 2x minus 2z plus 2y into z square plus zx minus 2y into y square minus xy. So here 2y cube minus 2y cube cancelled minus 2xy square here minus 2xy square here minus 2xy square here we'll get 2xy square plus cancelled and minus 2zy square here plus 2zy square will be cancelled and then minus 2yz minus 2 minus minus 2xyz here plus 2xyz will be cancelled and minus 2yz square plus 2yz square will be cancelled. All will be cancelled. We get 0. Therefore, given equation is integrable. So first we checked this equation is integrable. But this equation, we observe this equation cannot be integrable directly or by regrouping it cannot be integrable. So that's why to solve this equation, I have to take one variable as constant, either x or y or z can be taken as a constant. So I will take a z as constant. I will take can solve this equation, because this equation cannot be directly integrable, or this equation cannot be integrable by regrouping. So that's why I will take one variable as constant. You may take x is constant, y is constant, but I will take here z is constant. Here three variables are there, x, y, z. One variable will be taken as constant. So let z is constant. Therefore, this implies dz equals 0. Dz equals 0. So by 1, so dz is 0, we'll get y square plus yz dx plus z square plus zx dy equals 0. So write this here. Here z square by plus zx and y square plus y plus yz cross multiplication. So write here, write this. Or dividing by z square plus zx into y square plus yz. So dx by z square plus zx and dy by y square plus yz. So here we take important thing, this to solve this problem. One variable will be taken as constant. I have taken here z as constant. We get dz equals. Finally, we are getting dx by z square plus zx, dy by y square plus yz. So this can be written as 1 by z into z plus x dx plus 1 by y into y plus z dy. So write this z by cross multiplication right here. You get 1 by z plus x dx, z by y into y plus z dy equals 0. So integrating. So 1 by z plus x dx, z by y into y plus z dy equals 0. Now by partial fractions we write 1 by y minus 1 by y plus z. So you observe here y into y plus z minus y, we get z. So z by y into y plus z can be written as 1 by y minus 1 by y plus z dy. So here when integrating, we treat this z here, finally getting 1 by z plus x dx, 1 by y minus 1 by y plus z dy, integrating. So integral 1 by z plus x dx plus integral 1 by y minus 1 by y plus z dy equals 0. So when we are integrating this, we treat z as constant. We treat z as constant. Here like this, 1 by x plus a dx is a, that log x plus a. So here log z plus x. And we know that 1 by y dy is log y. This is like a 1 by y plus a constant. Z is constant. We write log y plus z. So I had write some constant, but we treat z as constant. That's why I have written here log phi z, log. So in place of constant, I have taken logarithm of phi z, because all are logarithm functions. That's why I have taken log some function of it, because we treat here z as constant. That's why in place of constant, I have written logarithm of phi z. So this is like log m plus n. So log m into n. This is minus n. So we know that log m plus log n equal to log mn, m into n. Log m minus log n equal to log m by. So log m minus log n equal to log m by. So finally, we are getting logarithm of y into z plus x by y plus. So whenever plus comes, log m plus log m is equal to log m into n. Whenever minus came, log m minus log m log m by. That's why. So it comes under denominator. Y play logarithm of y into z plus x by y plus z equal to logarithm of phi z. So finally, logarithm will be cancelled. You get y into z plus x by y plus z equal to function of z. So finally, we are getting this is take as 2 y into z plus x by y plus z equal to phi z. So y into z plus x is equal to y plus z phi z. So now differentiate with respect to x, y, z. So here yz plus yx minus of y plus z phi z is equal to 0. So differentiate with respect to x, y, z. So derivative of yz. So this is like derivative of yz means y dz plus z dy. Derivative of uv, you know that. U into derivative of v plus v into derivative. Right? This is for yx. Y dx derivative of uv. U into derivative of v plus v into derivative of u. So y dx plus x dy for this derivative. For this derivative, minus y plus z into derivative of phi z is phi dash z into dz. Phi dash z into dz. And the minus phi z into derivative of y plus z is dy plus dz. So we take here uv. We take here as a u plus v is u into v. So u is a y plus z, v is a phi z. So y plus z into, so u into derivative of v, phi dash z dz minus phi z into derivative of y plus z dy plus dz, that equal to 0. So finally we are getting y dx plus z dy plus y dx plus x dy minus y plus z pi dash z dz minus phi z dy plus dz. So now write dx one side, dx common, and dy common, dz common. Here only one term is in dx, y dx. For dy, three terms are there. One term is z plus x, another term is minus phi z dy. For dz, three terms are there. Y minus y plus z phi dash z minus phi z. So here dx common, only one term y dx. For dy two terms, three terms, z plus x minus phi z dy, and dz three terms. One is y minus y plus z phi dash z minus phi z dz equal to 0. So now comparing with the given equation, given equation is given equation is y square plus yz dx. Given equation is this is a this is given equation. Here y square plus yz dx, z square plus z dx dy, and y square minus 6y dz equal to 0. Comparing with the given equation, in the given equation, dx coefficient is y square plus yz, here by y, and in the given equation z square plus zx by, here dy coefficient is z plus x minus phi z, and in the given equation dz coefficient is y square minus xy by, here y minus y plus x phi dash z for minus phi. So from this, taking a first and last term, we'll get y square plus yz by y square plus yz plus y by y is equal to y square minus xy by y minus first and the last term we will take y minus y plus z phi dash z minus phi. So cross multiplication will get y square plus yz minus y minus y plus z phi dash z minus y z plus x by y plus z. Cross multiplication. So we'll get y into y square minus x, y into y square minus x. So, but phi z equal to phi z equal to phi z equal to y into z plus x by y plus z. Write this value. So cross multiplication, y square plus yz, y minus y plus z phi dash z minus phi z. Phi z is actually y into z plus x by y plus x. So this is equal to y into y square minus x. Taking common y plus z, y minus y plus z phi dash z minus y into z plus x by y plus z. So y will be cancelled, left and right hand side. So we'll get y into y square z into y plus yz, and y plus z whole square y dash z, y plus z whole square phi dash z. And for this last term, y plus z will be cancelled. We'll get here minus yz minus yx, minus yz minus 6 yx x. Right hand side we have y square minus 6y. So here yz will be cancelled, and y square left hand side y square, right hand side y square will be cancelled, and the left hand side xy minus xy, right hand side minus xy will be cancelled. Finally, we'll get minus y plus z whole square phi dash z equal to 0. Y z are variables, it cannot be 0, y plus z whole square. So only phi dash z is 0. So derivative is 0 means then that function must be constant. Derivative of a constant is 0. So that's why. So phi dash z equal to 0 implies phi z equal to constant. So therefore solution is. So we know that therefore solution in place of right into phi z. So y into z plus x by y plus z equal to phi z equals c. So that equal to y into z plus x is equal to c into y plus. So finally, to solve total differential equation p dx plus q dy plus r dz equal to 0. First, check the condition of the integrability. Check the condition of the integrability. Just first find determine PQR dou by dou x dou by dou y dou by dou z PQ. If this determinant equals 0, if this determinant equals 0, then the given equation is integrable. Here y square plus yz plus z square plus zx minus y square minus xy dou by dou x dou by dou y dou by dou z, this is 0. So therefore given equation is integrable. So whenever it is integrable, to solve this differential equation, total differential equation. So sometimes we can solve total differential equation directly by integrating or by regrouping the terms and we get the solution. But here we don't get like that. That's why we take one variable as constant. Either x or y or z. You can solve this. I have here taken z as constant, I solve. But you can take x is constant or y is constant. You can solve taking x as constant, y is also constant. You can solve this. Here once again we see that I have taken here z as constant. Z as constant. So automatically dz is 0. Dz is 0. So finally we are getting dz equal to c, dz equal to 0, y square plus yz dx plus z square plus zx dy equal to 0. So cross multiplication dx by z square plus zx dy by y square plus yz equals 0. So finally 1 by z plus 6 dx, 1 by y plus z dy. So right here z cross multiplication. So finally we are getting 1 by z plus 6 dx plus z by y into y plus z dy equals 0. So 1 by z plus x and 1 by z plus x dx. We write this by partial fractions 1 by y minus 1 by y plus z. Integrating, we'll get logarithm of z plus x plus log y minus log y plus z. I write here constant because we treat z as constant. I have written here log 5. So from this logarithm of z plus x into y by y plus z. Using this formula, log m plus log n equal log m n. Log m log n is equal to log m by. So finally we get logarithm of y into z plus x by y plus z equal to logarithm of 5z. So finally we are getting y into z plus x by y plus z equal to 5z. So this is now to if you find the 5z, you get the solution. Get a 5z value, just differentiate with respect to xyz. So differentiate with respect to xyz, we get y dz plus z dy. This is derivative of uv, y dx plus x dy. And here y plus z, derivative of uv, u into derivative of v, v into derivative of u. Y plus z, phi dash z dz minus phi z into dy dz, dy plus dz. So first I have checked condition of integrability and have taken z as constant and integrate, we get here we see as phi z. So to find phi z, differentiate with respect to x phi z and compare the right in the form p dx plus q dy plus r dz equal to 0, comparing with the given equation. The given equation p coefficient dx coefficient y square plus yz, here y, and q coefficient z square by z plus zx by here z plus x minus yz, here y square minus xy by y minus x plus z, here dz coefficient is this y minus y plus z phi dash z minus phi. Now we have to find from these three equations phi z. Taking first and third, we'll get y square plus yz by y square minus 6y by y minus y plus z, 5 dash z minus 5. So finally we are getting y square plus yz, y minus y plus z, 5 dash z minus this. So y into cross multiplication. So but we know 5z, here 5z is y into z plus 6 by x plus z. Here by taking common y will be cancelled. So y plus z into y minus y plus z, 5 dash z minus y into z plus 6 by y plus z. So here y square plus yz and minus y plus z, y plus z, y plus z, y plus z whole square, 5 dash z minus yz minus xy. Finally, we get cancelled yz, y square will be cancelled, minus xy cancelled. We get finally minus y plus z whole square, 5 dash z equals 0, 5 dash z equals c. Therefore, 5z is constant. The solution is y into z plus x by y plus z equals c. So therefore, just only 3 steps. First, verify the condition of the integrability, and then determine this determinant. Take one variable z as constant. I have taken z. We take x or y, and then we find phi z. We get this